To complete linear programming problems, these are from section 5.3. To enter them in your calculator, just a quick review here, you hit y equals, you go to your y equals menu, and of course you have to get your inequalities in y equals format. So if I want to graph y is greater than or equal to 4 minus 2x, I would just type in 4 minus 2x, and it's greater than or equal to. So to get greater than or equal to, I would scroll over to greater than or equal to, and to get greater than or equal to, I would go to the left and have those highlighted right there. I hit enter, and I hit enter. That one, upper right triangle, symbolizes greater than or equal to. So I would now go over and I could graph. Now, knowing that the restrictions are x is greater than or equal to 0 and y is greater than or equal to 0, I know that I'm only in the first quadrant. So I can go to my window. In first quadrant, I would set my x min to 0. My x max is 10, going by ones on the x scale. My y min will be 0. My y max will be 10. My y scale is 1. I can't have anything less than 0 on the y. I can't have anything less than 0 or equal to 0 on the x. So that's why I set those up that way. I can change the max as necessary so the graph will fit on my screen. I go to graph, and notice I have my graph of my solution, and it's only in the first quadrant. So the solution is where it is shaded, so it's everything above the x-axis over to this point, along that line, to that point and above. So this would be an unbound solution. I have a corner point here and a corner point here. I only have 2 corner points. Well, I know that one's the x-intercept and I know one's the y-intercept. So I could go to my table and find out what those are. So I hit second graph to go to my table. So I have a corner point at 0, 4 and a corner point at 2, 0. If I go to back to my graph, there is 2, 0, there is 0, 4, and I have those 2 corner points. I can plug those corner points into my objective function if I would have one, and I could see which one is the max or minimum value. Now, if I have multiple inequalities, let's go back to y equals. So if we have multiple inequalities to go along with our restrictions, and it's challenging to possibly find corner points, we have a little more work we're going to have to do. So, for example, if I take the inequality and plug it in for y is greater than or equal to 7 minus x. So I'm going to delete that out of there. So 7 minus x greater than or equal to, so I have the right triangle. And just be mindful that your calculator will not do less than or greater than, so you'll have to remember that those are dashed lines. Your second inequality will be the inequality of y is less than or equal to, so I go back over here and I change to less than or equal to. That's greater than or equal to. Lower left is less than or equal to. And I go over and put in my inequality. So it would be positive 2x minus 2. Hit graph. No, my restrictions are still x is greater than or equal to 0 and y is greater than or equal to 0. I know I'm still in my first quadrant. So where it is checkered is my solution. So solution is unbound. If this was my solution right here, it is not because it doesn't have the checkered pattern. This would be bound because it's all bounded underneath there. But since this one continues infinitely in that direction, infinitely in this direction, infinitely in that direction, it is unbound. I have a corner point here and a corner point here. Well, we know this corner point is the x-intercept, so I can go to my table, second graph, and find my x-intercepts. So I can scroll on. Oh, look at here. I have one at 1, 0. Well, we know, looking at our graph, 1, 0 can't be it. So let's go back to the table and see if there's another one. when y is 0. So are there any more y or zeros? Oh, there's a y that's 0. So 7, 0 would be a corner point. Yes, that makes sense. This is 7, 0 where it crosses the x-axis. That's a corner point. Now to find this one, you could try to estimate where it is. We also have this tool that we use when we solve systems of linear equations. We can find the intersection point. So we can hit second calculate, and we can go down to intersect. And we have our first curve. Well, if we can't see our cursor, I'm going to use the arrows to see if we can find it. There it is. So we want to get close to where those two lines intersect. So let's say right about there and hit enter. There's our first curve. And right there's the flashing cursor again. So that's close to that intersection point. So hit enter. Guess, who cares? Just hit enter. And there we have another corner point. That point is 3, 4. So the corner point 3, 4 and the corner point 7, 0. So we would plug those into the objective function if we had one and see whether those points are a max or min. This concludes the video on linear programming. If you have questions, please let me know.